Planet Jupiter. Jupiter, the largest planet in our solar system, has fascinated humanity for centuries with its immense size, mysterious swirling clouds, and powerful presence in the night sky. Visible even to the naked eye as one of the brightest objects among the stars, Jupiter has long captured the curiosity of astronomers, philosophers, and dreamers alike. It is not only a planet but a colossal giant whose influence extends far beyond its own orbit, shaping the architecture of the solar system itself. To write about Jupiter is to dive into a story of grandeur, complexity, and cosmic significance, a story of storms that have raged for centuries, moons that resemble worlds of their own, and forces of gravity so strong that they protect Earth in subtle but profound ways. At nearly 143,000 kilometers in diameter, Jupiter dwarfs every other planet. To grasp its magnitude, one must imagine that over 1,300 Earths could fit inside it. Yet despite its enormous bulk, Jupiter is not a solid world like our own. It is a gas giant, composed mostly of hydrogen and helium, the very same ingredients that form stars. This fact alone places Jupiter in a unique category. It stands on the boundary between planets and stars, embodying characteristics of both, but never crossing into the realm of nuclear fusion that powers the Sun. Had it been many times more massive, Jupiter might have ignited into a second star, and our solar system would have evolved into a binary star system rather than the single sun-dominated system we know today. The ancient civilizations who looked up at Jupiter in awe could not have known these scientific details, but they felt its significance nonetheless. In Roman mythology, Jupiter was named after the king of the gods, a fitting title for such a mighty celestial body. The Greeks before them called it Zeus, ruler of Mount Olympus. In cultures across the world, Jupiter was associated with power, protection, and authority. Its brightness in the heavens made it a guiding star for travelers and a subject of sacred importance for priests and scholars. Long before telescopes revealed its moons and swirling storms, Jupiter was already celebrated as a cosmic ruler, one whose dominance seemed unquestionable. When Galileo Galilei first pointed his telescope at Jupiter in 1610, a new chapter in human understanding began. He observed 4 small points of light, moons orbiting Jupiter, that challenged the long-standing belief that everything revolved around the Earth. These 4 moons, now known as the Galilean moons, Io, Europa, Ganymede, and Callisto, revealed that other celestial bodies could hold their own systems of motion. The discovery shook the foundations of science and religion, inspiring centuries of debate and ultimately laying the groundwork for modern astronomy. Today, these moons remain some of the most fascinating destinations in the solar system, each with its own mysteries and possibilities, from volcanic landscapes to hidden oceans that may harbor life. But Jupiter itself remains the centerpiece, a planet of unmatched complexity. Its atmosphere, filled with bands of clouds that circle the planet at immense speeds, creates a dazzling yet violent display. The alternating dark belts and bright zones are driven by ferocious winds, some reaching over 600 kilometers per hour. Within this dynamic atmosphere lies the famous Great Red Spot, a storm larger than Earth that has raged for at least 3 centuries. This immense tempest is one of the most iconic features in the solar system, a swirling vortex of power that symbolizes Jupiter's untamed nature. And yet, the red spot is just one feature in a planet that holds countless storms, cyclones, and shifting cloud patterns. Jupiter's gravity is another defining aspect. It is more than 2.5 times stronger than Earth's, an invisible force that not only shapes the planet itself, but also exerts a powerful influence on its surroundings. Jupiter acts as a cosmic shield, pulling in or deflecting asteroids and comets that might otherwise threaten Earth and the inner planets. Many astronomers believe that without Jupiter's protective role, life on Earth might not have had the chance to flourish, for the bombardment of cosmic debris could have been far more catastrophic. At the same time, Jupiter's gravity sculpts the orbits of its moons, creates intricate ring systems, and stirs the balance of the solar system in ways we are still striving to fully understand. Modern science, with its probes and telescopes, has peeled back some of the mystery of Jupiter, yet much remains hidden. Spacecraft such as Pioneer, Voyager, Galileo, and Juno have delivered breathtaking images and data, showing us glimpses of its storms, radiation belts, and magnetic field. But these missions only scratch the surface of a world that defies easy exploration. With no solid ground to land on, crushing pressures deep within its atmosphere, and radiation levels strong enough to disable unprotected electronics, Jupiter challenges us at every turn. It is a reminder of the scale and danger that lie beyond our home planet, and of the resilience required to seek knowledge among the stars. In this script, we will journey through the many dimensions of Jupiter: its size, structure, and atmosphere, its role in the solar system, its mesmerizing moons, its cultural importance throughout history, and the missions humanity has launched in pursuit of understanding. To write about Jupiter is to weave together science, myth, exploration, and wonder into one immense narrative. As we move deeper into the chapters that follow, we will uncover the layers of this gas giant and explore why Jupiter remains not just a planet, but a symbol of majesty, mystery, and power in the grand theater of the cosmos. To truly understand Jupiter, one must look beneath the shimmering clouds and attempt to uncover the hidden depths of this giant. Unlike Earth, with its solid crust and rocky foundation, Jupiter is a world without a true surface. Its composition is almost entirely gaseous, dominated by hydrogen and helium, the same basic elements that fuel stars. This gaseous nature makes Jupiter an enigma, a planet too massive and complex to fully grasp, yet one whose structure reveals crucial secrets about how planetary systems form and evolve. At first glance, Jupiter's outer layer appears to be a rolling ocean of clouds. These clouds are arranged in alternating bands that encircle the planet from pole to pole. Scientists call the lighter-colored bands zones and the darker bands belts. Zones are regions of rising gas, while belts represent sinking gas, and together they create the breathtaking striped appearance that makes Jupiter instantly recognizable. The clouds themselves are not simple water clouds like those on Earth. Instead, they are composed of ammonia crystals, ammonium hydrosulfide, and possibly water ice deeper below. These ingredients form the bright whites, browns, reds, and yellows that we see through telescopes, creating a living canvas of colors that constantly shift and evolve. Beneath these visible clouds lies a vast atmosphere stretching thousands of kilometers downward. Here, pressure and temperature climb dramatically as one descends. At the top of Jupiter's clouds, temperatures can be as low as -145 degrees Celsius, an icy environment compared to Earth's surface. Yet as one moves deeper, heat and pressure rise. The gases compress under the sheer weight of the planet's gravity, and hydrogen begins to behave in unusual ways. At certain depths, hydrogen transitions into a liquid state, forming vast oceans of liquid hydrogen unlike anything on Earth. Still deeper, hydrogen is compressed even further, turning into a bizarre and exotic form known as metallic hydrogen, a phase of matter in which electrons are free to move as they would in a metal. This metallic hydrogen is believed to be the key to Jupiter's powerful magnetic field, one of the strongest in the solar system. Scientists debate what lies at Jupiter's very center. Some theories suggest the presence of a rocky or icy core, perhaps 10 to 20 times the mass of Earth. Others argue that Jupiter may lack a distinct core at all, with heavy elements diffused throughout the planet's interior. The truth remains hidden beneath layers of immense pressure that no probe has yet penetrated. Even our most advanced spacecraft can only gather indirect evidence through gravitational measurements, leaving the deepest secrets of Jupiter shrouded in mystery. What is certain, however, is that the extreme conditions inside Jupiter offer insights into physics that cannot be replicated on Earth. The study of metallic hydrogen, for example, has implications not just for planetary science, but for our understanding of materials under extreme pressures. The atmosphere of Jupiter is perhaps its most famous feature. It is a dynamic and turbulent world dominated by jet streams, cyclones, and colossal storms. Winds can reach speeds exceeding 600 kilometers per hour, whipping the cloud tops into ever-changing patterns. Among these storms, None is more iconic than the Great Red Spot. This massive anticyclonic storm, first observed in the 17th century, is large enough to engulf Earth itself. For centuries it has raged on, its crimson hues standing out vividly against the surrounding clouds. While the Great Red Spot has gradually shrunk in size over the past century, it remains one of the most enduring and awe-inspiring features in the solar system. Scientists continue to study it closely, seeking to understand how such a storm can last for centuries in a way that no storm on Earth ever could. In addition to the red spot, Jupiter hosts countless other storms and vortices. Modern images from spacecraft such as Juno reveal intricate cloud systems dotted with swirling cyclones and anticyclones, particularly near the poles. Unlike Earth, where storms are often isolated, Jupiter's storms can cluster into vast patterns, interacting and colliding in ways that create mesmerizing geometric shapes. These storms, driven by the planet's rapid rotation, Jupiter completes one rotation in just under 10 hours, are sustained by the immense internal heat rising from within. In fact, Jupiter radiates more energy into space than it receives from the Sun, evidence of powerful processes occurring in its deep interior. The rapid rotation of Jupiter not only drives its storms but also flattens the planet at the poles, giving it an oblate shape. Unlike Earth, which is nearly spherical, Jupiter bulges noticeably at its equator due to the speed of its spin. This characteristic, combined with its colorful bands and raging storms, makes Jupiter a dynamic and ever-changing planet, one whose very appearance speaks to its restless nature. The chemical composition of Jupiter's atmosphere provides further clues about its origins. Alongside hydrogen and helium, traces of methane, ammonia, water vapor, and other hydrocarbons are present. These compounds, while small in quantity compared to the bulk gases, play a crucial role in shaping the planet's weather and cloud patterns. The presence of water, in particular, has fascinated scientists, for water may hold the key to understanding Jupiter's formation. By measuring the abundance of water deep in its atmosphere, scientists can piece together the story of how Jupiter accumulated material during the early days of the solar system. The ongoing Juno mission has been tasked with probing this question, using its instruments to scan below the clouds and measure water content, among many other properties. Another striking aspect of Jupiter's structure is its enormous magnetosphere, the region dominated by its magnetic field. Though technically linked to its core and interior processes, the magnetosphere extends far into space, enveloping the planet in a protective bubble that dwarfs the Sun itself. Jupiter's magnetic field is about 20,000 times stronger than Earth's, and its reach can stretch millions of kilometers, even influencing the orbit of some of its moons. Within this field, charged particles are trapped and accelerated, creating intense radiation belts that pose a significant hazard to spacecraft. These belts are so powerful that they can damage electronics and threaten unshielded instruments within hours of exposure. Understanding the connection between Jupiter's metallic hydrogen interior and its vast magnetosphere remains one of the central goals of planetary science. In summary, Jupiter's structure is a layered symphony of gases, pressures, and forces. From its colorful ammonia clouds to its mysterious possible core, from its raging storms to its exotic metallic hydrogen, Jupiter represents both a scientific challenge and a source of endless fascination. To study Jupiter is to confront the unknown, to peer into conditions that defy easy replication, to test theories of planetary formation, and to wrestle with the very physics of matter under extreme environments. The more we learn, the more Jupiter surprises us, reminding us that this colossal world is not simply a planet, it is a frontier of discovery, a natural laboratory that continues to expand our imagination of what is possible in the universe. If Jupiter were merely a giant ball of swirling gases, it would still inspire awe. But what truly makes it extraordinary is not only its own size and power, but the family of moons that orbit it, a miniature solar system within our solar system. With at least 95 known moons, Jupiter holds more natural satellites than any other planet except Saturn. These moons range from tiny, irregularly shaped rocks only a few kilometers wide to massive worlds rivaling Mercury in size. Among them, stand out as the crown jewels, The Galilean moons, Io, Europa, Ganymede, and Callisto, first observed by Galileo Galilei in 1610. These four moons are so large and remarkable that they could easily be planets in their own right, each possessing unique characteristics that have captivated scientists for centuries. The innermost of the Galilean moons, Io, is unlike any world we know. It is the most volcanically active body in the solar system, covered in hundreds of active volcanoes that spew lava fountains dozens of kilometers into the sky. Its surface is a constantly changing mosaic of sulfur, molten rock, and volcanic plains, painted in hues of yellow, red, and black. Unlike Earth's volcanism, which is driven by plate tectonics and internal heat, Io's fiery activity is caused by tidal heating. As Io orbits Jupiter, it is pulled and stretched by the giant planet's immense gravity, as well as by the gravitational tugs of Europa and Ganymede. This constant tug-of-war creates friction and heat inside Io, enough to melt rock and drive continuous eruptions. For a world that is roughly the size of Earth's moon, Io is astonishing in its dynamism. The volcano Loki Patera, one of Io's most famous volcanic regions, is hundreds of kilometers wide and periodically undergoes massive eruptions that can alter the moon's surface on a global scale. The extreme environment makes Io one of the most hostile places imaginable. Its thin atmosphere, composed mainly of sulfur dioxide, offers no protection, and radiation from Jupiter's magnetic field bombards it relentlessly. Yet despite, or perhaps because of, its violence, Io offers invaluable insights into planetary processes. By studying Io, scientists learn how tidal forces can shape worlds, how heat is generated in extreme environments, and how volcanic activity can influence atmospheres and surfaces on a planetary scale. Just beyond Io lies Europa, a moon that has become a prime target in the search for extraterrestrial life. Europa's surface is a dazzling sheet of ice, cracked and scarred by streaks that stretch across its entire globe. Beneath this icy crust, scientists believe, lies a vast subsurface ocean containing more water than all of Earth's oceans combined. The evidence comes from magnetic field data, surface features, and models of tidal heating similar to Io's. If Europa does indeed harbor a liquid ocean beneath its ice, it could be one of the most promising habitats for life beyond Earth. The icy surface of Europa is not static. It shows signs of movement and renewal, with regions where the ice has fractured and refrozen, suggesting that liquid water or slushy material occasionally rises closer to the surface. In some cases, geysers of water vapor may even erupt from cracks, releasing plumes that could one day be sampled by spacecraft. These possibilities have made Europa a focal point for missions such as NASA's upcoming Europa Clipper, which will explore its surface and environment in unprecedented detail. The question driving this exploration is profound. Could microbial life thrive in Europa's hidden ocean, sheltered from radiation and warmed by tidal heating? The possibility makes Europa not only one of Jupiter's most intriguing moons, but one of the most exciting worlds in the entire solar system. Ganymede, the largest moon of Jupiter, is the largest moon in the solar system and the only one known to possess its own magnetic field. Bigger than the planet Mercury, Ganymede is a world of staggering scale. Its surface is a patchwork of older, heavily cratered regions alongside lighter, grooved terrains created by tectonic processes. These grooves stretch across the surface for thousands of kilometers, hinting at geological activity in the moon's past. Like Europa, Ganymede is believed to harbor a subsurface ocean sandwiched between layers of ice. This ocean, combined with its unique magnetic field, makes Ganymede a compelling object of study. The presence of a magnetic field suggests that liquid, electrically conducting material exists within its interior, possibly a salty ocean or partially molten core. Auroras dance around Ganymede due to interactions between its field and Jupiter's massive magnetosphere, creating visual spectacles that no human eye has yet seen directly, but that instruments have detected from afar. The sheer scale of Ganymede and its internal complexity remind us that moons are not merely passive companions of planets. They can be dynamic, planet-like worlds in their own right. The outermost of the Galilean moons, Callisto, offers a stark contrast to its siblings. While Io burns with volcanic fury, Europa glistens with youthful ice, and Ganymede hums with internal magnetism, Callisto is ancient and quiet. Its surface is the most heavily cratered in the solar system, bearing scars that date back billions of years. Unlike the others, Callisto shows little evidence of internal activity or geological renewal. It is a relic of the early solar system, a frozen time capsule preserving the record of impacts and processes from eons past. Despite its apparent inactivity, Callisto has its own allure. Beneath its icy crust, scientists suspect there may also be a subsurface ocean, though deeper and less accessible than Europa's. The moon's distance from Jupiter means it experiences less tidal heating, which likely explains its stillness compared to its neighbors. Yet its stability has advantages. Unlike Io, which is bombarded with intense radiation, Callisto lies farther from Jupiter's radiation belts, making it one of the safer environments for future human exploration or even colonization. Some mission concepts have proposed using Callisto as a base for further exploration of the Jovian system, taking advantage of its relative safety and its resources of ice and rock. Beyond the Galilean moons lies a swarm of smaller satellites, numbering in the dozens. Many of these moons are irregularly shaped, likely captured asteroids or remnants of collisions. While they may not command the same attention as Io or Europa, these moons add to the complexity of Jupiter's system. They orbit at varying distances and inclinations, forming groups that reflect their origins. Some are retrograde, orbiting in the opposite direction of Jupiter's rotation, suggesting that they were captured from elsewhere in the solar system. Others are part of families created when larger bodies were shattered by impacts. Together, these smaller moons paint a picture of Jupiter as not just a planet, but a gravitational dominion, a massive center of attraction whose influence has gathered and shaped countless bodies over billions of years. Studying them helps astronomers understand the chaotic processes of capture, collision, and orbital evolution that have sculpted the outer solar system. When viewed as a whole, Jupiter and its moons resemble a miniature solar system. The Galilean moons orbit in a resonant dance, their gravitational pulls locked in patterns that stabilize their orbits and drive tidal heating. This resonance ensures that Io, Europa, and Ganymede remain in constant gravitational interplay, fueling volcanism, sustaining subsurface oceans, and shaping their destinies. In many ways, Jupiter's moons mirror the diversity of planets themselves. Fiery Io like a volcanic Earth on overdrive, icy Europa a potential ocean world, massive Ganymede a magnetic giant, and ancient Callisto a frozen relic. This diversity transforms Jupiter from a single planet into a realm of exploration in itself. Each moon offers a different face of possibility: the study of geological extremes, the search for life, the exploration of magnetic fields, and the preservation of solar system history. Together, they ensure that Jupiter is not merely a gas giant orbiting the Sun, but a cosmic kingdom, a system rich with worlds that expand our definition of what it means to be a planet's satellite. When people think of rings in the solar system, Saturn naturally comes to mind. Its spectacular rings dominate astronomy books and telescope images. Yet Saturn is not the only planet with rings. Jupiter, too, possesses a faint and delicate ring system that is often overlooked. Though far less dramatic than Saturn's, Jupiter's rings add another layer of complexity to its planetary character. They are composed primarily of fine dust particles rather than bright ice chunks, making them nearly invisible from Earth. Only when spacecraft such as Voyager 1, Voyager 2, and later Galileo passed by Jupiter did scientists confirm their existence. Jupiter's rings consist of 4 main components: the halo ring, the main ring, and 2 gossamer rings. The halo ring is a faint, broad torus of material surrounding the planet closest in. Outside of it lies the main ring, a thin, narrow band that is more distinct than the others. Beyond that stretch the gossamer rings, which are wider and more diffuse. These outer rings are associated with small moons such as Amalthea and Thebe, which shed dust due to micrometeorite impacts. Unlike Saturn's icy rings, which reflect sunlight brilliantly, Jupiter's dust-based rings are dark, reddish, and ghostly, whispering of quiet processes rather than dazzling spectacle. The very existence of Jupiter's rings speaks to the constant recycling and reshaping of material around the planet. Tiny particles are constantly supplied by moonlight struck by space debris, while at the same time, Jupiter's strong magnetic field and radiation gradually strip material away. It is a balance of supply and erosion, a delicate dance of matter circling a giant. Though less prominent than Saturn's, Jupiter's rings remind us that even the largest planet in the solar system has its own halo, a crown of dust marking its domain. Yet if the rings represent Jupiter's quiet side, its magnetic field and radiation belts reveal its violent and powerful face. Jupiter's magnetic field is the largest and strongest of any planet in the solar system, stretching millions of kilometers into space. Generated deep within the planet by the movement of metallic hydrogen, this field creates a magnetosphere so vast that if it were visible from Earth, it would appear larger than the moon in our night sky. It is a structure of staggering scale, dwarfing not just the planet itself, but even the sun when measured across certain distances. Within this enormous magnetosphere, particles are trapped and accelerated to extreme energies, creating intense radiation belts. These belts are far stronger than Earth's Van Allen belts and are deadly to unprotected spacecraft. Instruments and electronics exposed to this environment without heavy shielding can fail within hours. Even the most advanced missions, such as Galileo and Juno, have had to carefully design orbits and shielding to survive Jupiter's radiation onslaught. The radiation also bombards Jupiter's moons, especially Io and Europa, altering their surfaces and atmospheres in ways that shape their environments profoundly. The auroras of Jupiter provide a visible manifestation of this magnetic power. At the planet's poles, charged particles funnel down magnetic field lines and strike the atmosphere, creating brilliant displays of ultraviolet and infrared light. Unlike Earth's auroras, which are often fleeting and dependent on solar activity, Jupiter's auroras are permanent, powered not only by the solar wind but also by the volcanic activity of Io. As Io erupts, it spews sulfur and oxygen ions into space, which become trapped by Jupiter's magnetic field. These ions are carried along, creating electrical currents that feed directly into the auroral regions. Thus, the auroras of Jupiter are not just beautiful, they are direct evidence of the interconnectedness of the Jovian system, where planet and moon exchange energy in constant interaction. Beyond its magnetic field, Jupiter plays an even grander role, that of cosmic protector. Its immense gravity acts as a guardian for the inner solar system, pulling in or deflecting countless comets and asteroids that might otherwise collide with Earth or other terrestrial planets. This protective function is not theoretical, it has been observed directly. In 1994, astronomers witnessed the dramatic collision of Comet Shoemaker-Levy 9 with Jupiter. Broken into fragments by the planet's gravity, the comet plunged into the atmosphere, releasing explosions larger than Earth itself. The impact scarred Jupiter's clouds with dark spots that persisted for weeks, visible reminders of the cataclysmic event. Had Jupiter not intercepted this comet, its fragments might have posed a threat to Earth. Some scientists argue that Jupiter's gravitational presence was crucial to Earth's history. In the early solar system, when debris was abundant, Jupiter likely cleared or captured many dangerous objects, reducing the bombardment of the inner worlds. Without Jupiter acting as a cosmic shield, Earth's surface may have suffered too many catastrophic impacts for life to ever gain a foothold. While not every object is deflected, some trajectories are altered in ways that send comets inward. Jupiter's overall influence has dramatically shaped the environment of the solar system, balancing chaos with protection. But Jupiter's role is not only protective, it is also disruptive. Its massive gravity sculpts the asteroid belt, preventing the formation of another planet between Mars and Jupiter. Instead of coalescing into a world, the material in that region remains fragmented, endlessly stirred by Jupiter's pull. In the outer solar system, Jupiter's gravity affects the orbits of other gas giants, contributing to the overall stability of their motions. It is both guardian and architect, shaping the solar system's past and ensuring the balance of its present. The power of Jupiter's influence underscores a broader truth. It is not merely a planet, but a force of nature. Its rings remind us of the quiet processes of dust and debris. Its magnetic field reveals the violence of charged particles and auroras. Its radiation demonstrates the extreme hazards of space, and its gravity shows how one world can dictate the destinies of countless others. To study Jupiter is not only to learn about a single planet, but to understand the architecture of the solar system itself and the subtle yet profound ways in which giant planets govern the fate of smaller ones. For most of human history, Jupiter was known only as a bright wanderer in the night sky, a glowing orb whose steady brilliance inspired myths and mysteries. With the invention of the telescope, Galileo revealed that Jupiter had moons, showing that the universe was more complex than anyone had imagined. Yet even then, Jupiter remained distant and unreachable, its swirling storms and massive bulk beyond the grasp of human technology. That began to change in the 20th century, when the space age opened new frontiers. Step by step, robotic explorers ventured outward, carrying cameras, instruments, and curiosity into the vastness of the solar system. Among their most important destinations was Jupiter, the king of planets. The first spacecraft to visit Jupiter were Pioneer 10 and Pioneer 11, launched in the early 1970s. These missions marked humanity's first direct encounters with the gas giant, blazing a trail into uncharted territory. Pioneer 10 flew past Jupiter in December 1973, sending back the first close-up images of the planet. These photographs revealed details of the atmosphere that had never been seen before, along with measurements of its radiation belts and magnetic field. For the first time, Jupiter was no longer just a distant disk in telescopes. It was a dynamic world with storms, clouds, and immense forces waiting to be studied. Pioneer 11 followed in 1974, passing even closer to Jupiter. It confirmed and expanded upon the discoveries of its predecessor, offering more precise data about the planet's mass, composition, and powerful magnetic environment. Together, the Pioneer missions laid the groundwork for all future explorations of Jupiter. They showed that spacecraft could survive the treacherous radiation and provided crucial navigation experience for missions that would follow. More than scientific ventures, they were pioneering steps in humanity's first attempts to reach the outer solar system. The true revolution in our understanding of Jupiter came with the Voyager missions. Launched in 1977, Voyager 1 and Voyager 2 carried far more advanced instruments than the Pioneer probes. When they flew past Jupiter in 1979, the results were nothing short of astonishing. The Voyagers sent back thousands of high-resolution images, revealing the planet in breathtaking detail. For the first time, scientists saw the Great Red Spot up close, along with countless other storms swirling across Jupiter's vast face. The banded atmosphere, with its alternating belts and zones, came alive in color and motion. Yet the greatest surprises came not from Jupiter itself, but from its moons. The Voyagers revealed Io's incredible volcanic activity, capturing plumes of sulfurous lava erupting into space, something no one had expected. Europa's surface, with its smooth ice and mysterious cracks, hinted at the possibility of an ocean beneath. Ganymede and Callisto showed unique terrains, each with its own history. In one mission, the Voyagers transformed our view of Jupiter from a giant gas planet into the center of a miniature solar system filled with astonishing worlds. The Voyager missions also discovered Jupiter's faint ring system, something the Pioneer probes had only hinted at. This revelation showed that rings were not unique to Saturn, but part of a broader family of features among gas giants. Voyager also measured the strength of Jupiter's magnetic field and the vastness of its magnetosphere, confirming its status as the largest and most powerful in the solar system. These missions left an enduring legacy, providing data that scientists continue to analyze decades later. If Voyager was the scout that revealed Jupiter's wonders, Galileo was the explorer that lingered to study them in depth. Launched in 1989, Galileo arrived at Jupiter in 1995 and became the first spacecraft to orbit the planet. Over the next 8 years, it conducted an extended mission, circling Jupiter and making repeated flybys of its moons. The Galileo spacecraft revolutionized our understanding of the Jovian system in ways no brief flyby ever could. One of Galileo's most significant contributions was its study of Jupiter's atmosphere. Before entering orbit, the spacecraft released a probe that plunged directly into the planet's atmosphere, transmitting data as it descended. For nearly an hour, until the crushing pressures and heat destroyed it, the probe measured winds, temperatures, and chemical composition, offering humanity the first, and so far only, direct sampling of Jupiter's atmosphere. The data revealed fierce winds and unexpected dryness in the region where the probe fell, challenging existing models and reminding scientists of Jupiter's complexity. Galileo also provided extraordinary insights into the Galilean moons. Its close flybys of Europa revealed evidence of a global subsurface ocean beneath the icy crust, sparking intense interest in the possibility of extraterrestrial life. Ganymede was found to possess its own magnetic field, the only moon known to do so, adding to its uniqueness. Io's volcanic activity was studied in detail, with eruptions and lava flows captured in stunning imagery. Callisto, with its ancient, cratered surface, was examined as a record of solar system history. Through Galileo, each of these moons became more than a dot of light. They became worlds with personalities, mysteries, and potential. Yet Galileo's mission was not without challenges. A malfunction prevented its high-gain antenna from fully deploying, limiting its ability to send data back to Earth. Despite this setback, engineers and scientists worked ingeniously to maximize the spacecraft's capabilities, ultimately gathering far more information than expected. In 2003, after years of groundbreaking science, Galileo's mission ended when the spacecraft was deliberately plunged into Jupiter's atmosphere. This final act ensured it would not accidentally crash into and contaminate Europa or another potentially habitable moon, preserving them for future exploration. In 2016, a new chapter in Jupiter exploration began with NASA's Juno spacecraft. Unlike Galileo, which orbited Jupiter's equatorial plane, Juno follows a highly elliptical polar orbit, diving close to the planet before swinging far away, allowing it to avoid the worst of the radiation. Its mission is focused on probing Jupiter's deep interior, magnetic field, and atmosphere, using instruments capable of peering beneath the clouds. Juno has already provided extraordinary discoveries. Its images, taken by the Juno cam, reveal Jupiter's poles as never before, swirling cyclones clustered in geometric patterns, unlike anything seen elsewhere in the solar system. Its instruments have detected ammonia weather systems, revealing that Jupiter's atmosphere is far more complex and dynamic than previously thought. Juno has also measured the planet's gravitational field with unprecedented precision, offering clues about whether Jupiter has a solid core. The data suggests that instead of a compact core, Jupiter may have a fuzzy interior with heavy elements dispersed throughout. This challenges older models and has forced scientists to rethink how gas giants form. Juno continues to orbit Jupiter today, extending its mission with new objectives, including detailed studies of Ganymede, Europa, and Io during close flybys. It has become not just a mission about Jupiter, but about the entire Jovian system, bridging the gap between planetary science and the search for habitability on icy moons. The story of exploring Jupiter is far from over. Upcoming missions promise to reveal even more. The European Space Agency's JUICE, Jupiter Icy Moons Explorer, launched in 2023, is on its way to study Ganymede, Europa, and Callisto in detail, with a special focus on their oceans and potential for life. NASA's Europa Clipper, set to launch later this decade, will conduct dozens of close flybys of Europa, searching for signs of habitability and investigating its icy crust and subsurface ocean. These missions represent the next great leap in our exploration of Jupiter's moons, turning science fiction dreams into concrete plans. Each spacecraft that visits Jupiter deepens our understanding, yet also raises new questions. From Pioneer's first snapshots to Juno's deep probing, we have learned that Jupiter is not a single world, but a system of worlds, a laboratory of storms, magnetism, oceans, and volcanic fire. The quest to understand it is far from finished. As technology advances and humanity dreams of future exploration, perhaps even robotic submarines beneath Europa's ice, Jupiter will remain a beacon of discovery, reminding us that the solar system still holds vast wonders waiting to be unveiled. Long before telescopes revealed Jupiter's storms and moons, ancient peoples gazed up at the night sky and saw a luminous traveler wandering among the stars. Its brilliance and slow, steady motion set it apart from the other wandering lights, inspiring awe and reverence. Across cultures, Jupiter became not merely a planet, but a symbol of power, authority, and protection. It entered the human imagination as a cosmic ruler, a celestial embodiment of kingship and justice. To study the cultural role of Jupiter is to trace the ways humanity has always sought meaning in the heavens. The very name Jupiter comes from Roman mythology, where Jupiter, or Jove, was the king of the gods. He was associated with thunder, lightning, and law, embodying both immense power and divine order. In mythology, Jupiter wielded a thunderbolt as his weapon, ruling the heavens and protecting the state. His Greek counterpart, Zeus, occupied a similar position in Greek religion, standing as ruler of Olympus, father of gods and men, and enforcer of justice. This mythological association is fitting for the largest planet in the solar system. Just as Jupiter or Zeus dominated the pantheon, so too does the planet dominate the night sky, brighter than nearly all the stars. Ancient observers, who saw the heavens as a mirror of divine order, naturally associated such a majestic planet with supreme authority. Even today, the names of Jupiter's largest moons, Io, Europa, Ganymede, and Callisto, reflect the mythology of Zeus, recalling the companions and lovers of the great god. Thus, astronomy and mythology remain intertwined, with modern science preserving echoes of ancient belief. Beyond Greece and Rome, Jupiter was revered across civilizations. In Mesopotamia, it was associated with the god Marduk, a deity of creation and rulership who defeated chaos and brought order to the cosmos. Babylonian astronomers, among the most advanced of the ancient world, carefully tracked Jupiter's movements, linking them to omens of kingship, prosperity, and justice. In Hindu tradition, Jupiter is known as Brihaspati or Guru, the teacher of the gods and the personification of wisdom. In Vedic astrology, Brihaspati represents knowledge, spirituality, and guidance, and its placement in a birth chart is said to influence morality, education, and fortune. Similarly, in Chinese astronomy, Jupiter was associated with the wood element, symbolizing growth and harmony. Its 12-year orbital cycle inspired the structure of the Chinese zodiac, where each year is linked to one of 12 animals. Thus, the rhythm of Jupiter's journey across the sky helped shape cultural calendars and systems of time. From Mesopotamia to India to China, Jupiter has consistently been seen as a planet of power, wisdom, and influence, a cosmic teacher and ruler who shapes human destiny. In Western astrology, Jupiter is known as the Great Benefic. Traditionally, it is associated with good fortune, expansion, wisdom, and generosity. Where Saturn represents limits and discipline, Jupiter embodies growth, optimism, and abundance. Its position in a horoscope is said to influence prosperity, philosophy, and spiritual development. For centuries, astrologers have viewed Jupiter as a guiding light, a planet that encourages exploration of both the physical and intellectual realms. Even if modern science rejects astrology as a predictive tool, the symbolism remains culturally significant. Jupiter's massive size and powerful presence in the sky made it a natural candidate for such associations. To human eyes, Jupiter appears as a beacon of steadiness and brilliance, and so it became a symbol of protection, luck, and expansion, qualities that endure in astrological interpretations today. The planet has also inspired poets, writers, and artists throughout history. Dante, in his Divine Comedy, places Jupiter as the celestial sphere of justice, populated by righteous rulers whose souls form the shape of an eagle, symbolizing divine law. In William Blake's mythological universe, Jupiter, or Jove, appears as a symbol of authority and sometimes tyranny, reflecting humanity's struggle with power and divinity. Artists of the Renaissance, influenced by classical mythology, often depicted Jupiter as the mighty king of gods, wielding thunderbolts or presiding over scenes of grandeur. Later, with the advent of telescopes, Jupiter's moons and storms became subjects of astronomical sketches and paintings, merging science with artistry. Today, digital art and photography from spacecraft like Juno continue this tradition, presenting Jupiter not just as a scientific object, but as a source of wonder and inspiration. In the modern era, Jupiter's influence has extended into music, film, and popular culture. Gustav Holst's orchestral suite The Planets includes Jupiter, the bringer of jollity, a movement that captures the planet's grandeur and uplifting spirit through soaring melodies. In science fiction, Jupiter and its moons often serve as settings for adventure and mystery, whether in Arthur C. Clarke's 2001, A Space Odyssey, which envisioned alien monoliths near Jupiter, or in countless films and novels where Europa's hidden ocean becomes a cradle of life. The planet's sheer scale and majesty make it a natural backdrop for tales of exploration, discovery, and existential reflection. It is both a real world and a symbol, a reminder of the universe's immensity and of humanity's small but determined place within it. Jupiter's cultural role cannot be separated from its physical reality. Its storms, magnetic field, and moons all inspire a sense of the sublime, the combination of awe and fear at encountering something vast beyond comprehension. To ancient peoples, that vastness became divine authority. To modern minds, it is a frontier of science and imagination. The mythology of Jupiter as a king, teacher, and protector remains deeply resonant, even as we learn about ammonia clouds and cyclones from spacecraft data. The planet embodies a dual legacy. It is both a subject of rigorous scientific study and a timeless symbol of order, justice, and grandeur. This duality reflects the way humans relate to the cosmos, not only as observers of physical reality, but as storytellers who weave meaning into the stars. Jupiter is more than a planet. It is a world of storms and secrets, a giant so immense that it could swallow all the other planets of the solar system and still have space to spare. It is a protector, deflecting comets and asteroids with its massive gravity, yet also a destroyer, reshaping the paths of countless celestial wanderers. It is a planet of contradictions, violent storms and delicate rings, crushing pressure and delicate auroras, a giant that both inspires fear and awakens wonder. To understand Jupiter is to understand a central force in the solar system, a planet whose presence has shaped not only the orbits of worlds, but the imagination of humanity itself. From the first skywatchers who looked up and saw a wandering star of unmatched brightness, to the mythmakers who crowned it king of the gods, Jupiter has always been associated with power, protection, and order. Its steady glow has been a source of guidance, its slow journey through the constellations a cosmic clock for civilizations. In mythology, it was Zeus, Jove, Marduk, Brihaspati, and the Wood Star, always a figure of wisdom, rulership, and expansion. Through the stories told around campfires and temples, Jupiter was never just light in the sky. It was meaning incarnate, a reflection of humanity's search for order in the cosmos. Science, however, has revealed Jupiter to be even more wondrous than myth. Telescopes showed its moons, a discovery that shattered old models of the universe. Probes revealed its storms, rings, and volcanic satellites, expanding the definition of what a planetary system could be. Galileo's descent into its atmosphere brought us into the heart of the giant, while Juno's polar orbits revealed patterns of cyclones that seem almost like cosmic art. Each mission has peeled back a layer of mystery, yet each answer only deepens the questions. What lies within its swirling depths? How exactly did it form? What role did it play in shaping Earth and making life possible? Could its icy moons, warmed by tidal forces, harbor alien oceans teeming with unseen life? Jupiter is not just a subject of curiosity, it is a keystone of cosmic history. Without it, the early solar system might have been a place of endless chaos, with Earth pummeled by asteroids beyond repair. Its gravity shaped the asteroid belt, sculpted the paths of comets, and may even have helped deliver water to our planet. In a real sense, Jupiter is part of the reason we are here. To study Jupiter is to study not only a distant gas giant, but also the conditions that allowed Earth to thrive. And yet, Jupiter is also a mirror of human ambition. Its vastness humbles us, reminding us of our fragility in the face of cosmic forces. At the same time, it inspires us to reach farther, to build spacecraft capable of surviving its radiation, to dream of probes diving beneath the ice of Europa or skimming the lava plains of Io. It is a challenge and a promise, a reminder that the universe is immense, but also that human curiosity has no boundaries. As we look to the future, missions like Europa Clipper and JUICE will extend the story of Jupiter, exploring its moons and probing their oceans for signs of life. Perhaps one day, human technology will send robotic submarines beneath Europa's crust or explorers to orbit Ganymede. Each step will bring us closer to answering one of humanity's greatest questions. Are we alone? If life exists elsewhere in the solar system, Jupiter's moons are among the most promising places to find it. In the end, Jupiter embodies the eternal dialogue between mystery and discovery. It is both a storm-ridden giant of hydrogen and helium and a symbol of kingship and justice. It is both a real place, mapped by spacecraft, and a timeless figure in our stories. It is the bridge between science and imagination, between what we know and what we dream. When we gaze upon Jupiter through a telescope or see the dazzling images sent back by spacecraft, we are not only looking at a planet, we are looking at a reminder of the cosmos itself, vast, powerful, and filled with endless wonders. Jupiter calls us to explore, to learn, and to dream. It tells us that beyond our small world lies a universe of giants, storms, oceans, and mysteries waiting to be discovered. And so, Jupiter remains what it has always been, the king of planets, the guardian of worlds, and a beacon of human curiosity. Its story is not finished, it has only begun.